Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P0712, indicating a CVT fluid temperature sensor short, specifically for Honda Fit models from 2015 to 2020. Understanding this Diagnostic Trouble Code, DTC, is vital for effective troubleshooting and repair. The CVT, or continuously variable transmission, relies on accurate fluid temperature readings to optimize performance and prevent overheating. Any short circuit in the temperature sensor circuit can escalate to significant transmission issues if left unaddressed. It's crucial to acknowledge that this error typically stems from electrical circuit issues rather than mechanical faults within the transmission system itself. With this insightful guide, you'll navigate the troubleshooting process systematically and effectively. The DTC P0712 pertains to the CVT Fluid Temperature Sensor, which plays a vital role in ensuring the optimal function of the continuously variable transmission. This sensor is situated within the transmission fluid, where it continuously monitors the temperature of the fluid. Accurate temperature readings are essential, as they inform the Powertrain Control Module, PCM, about the transmission's operating environment. The PCM then uses this information to make real-time adjustments to the transmission's operation, promoting efficiency and longevity. In essence, if this sensor fails or shorts, it sends incorrect data to the PCM, potentially leading to poor transmission performance or even failure. DTC P0712 can be traced back to several possible causes. Primarily, it stems from an electrical circuit problem, which indicates an issue within the wiring or connections associated with the CVT fluid temperature sensor. A faulty temperature sensor itself can also trigger this DTC, compromising the accuracy of the fluid temperature readings. Additionally, a short to ground in the wiring, often caused by damaged insulation or corrosion, can cause the sensor to report erroneous data, leading to malfunction. It's important to systematically investigate these areas to accurately diagnose and rectify the issue. The symptoms associated with DTC P0712 can be quite concerning for vehicle owners. Firstly, erratic transmission behavior may present itself, where the vehicle may not shift smoothly or as expected due to incorrect data being relayed to the PCM. This can lead to poor acceleration, where the vehicle may struggle to gain speed or respond poorly to throttle input. Another serious symptom is the potential for transmission overheating, as improper fluid temperatures can result in increased friction and wear on internal components. Given these serious implications, it's crucial to address the DTC promptly. In the first troubleshooting step for DTC P0712, start by turning the vehicle to the on mode without starting the engine. Then, utilize the Honda Diagnostic System, HDS, to check the parameters of the CVT fluid temperature sensor. Specifically, you're looking for the signal output voltage from the sensor, which should be less than 0.07 volts under normal operating conditions. If the current condition matches this threshold, it confirms that the failure condition is duplicated, allowing you to proceed to the next step. However, if the readings do not align with expectations, it is indicative of an intermittent failure. In that case, focus on checking for poor connections and loose terminals between the transmission fluid temperature sensor and the PCM. For the second troubleshooting step, begin by switching the vehicle to the off or lock mode. Next, disconnect the solenoid wire harness 8P connector located on the engine side of the harness. After disconnecting, turn the vehicle back to the on mode without starting the engine again. Once again, use the HDS to measure the voltage from the CVT fluid temperature sensor. This reading should also register as less than 0.07 volts. If this condition is met, the transmission fluid temperature sensor is operationally sound, and you may proceed to the next troubleshooting step. Conversely, if the voltage exceeds this threshold, it indicates that the sensor is faulty, prompting its replacement. In the final troubleshooting step, again, ensure that the vehicle is turned to the off or lock mode. This time, you will jump the SCS service check signal line using the HDS to bypass any potential communication issues during your testing. After successfully jumping the SCS line, disconnect the PCM connector C, which features a 51-pin configuration. Following this disconnection, you must check for continuity between two specific test points. Test point 1, located at PCM connector C pin number 37, and test point 2, which is the body ground. If continuity is confirmed, it indicates a short to ground in the transmission automatic transmission fluid, TATF wire, which runs between the solenoid wire harness and the PCM. Repair this short to ensure proper functioning. If no continuity exists, the TATF wire is deemed okay, and the next course of action includes checking if the PCM software is up to date or substituting it with a known good unit for further evaluation. Once the troubleshooting and repair process for DTC P0712 is completed, it's imperative to perform a final verification to ensure that the issue has been effectively resolved. First, recheck the DTC status using the HDS to confirm that DTC P0712 no longer appears. A successful repair will result in the absence of this code, indicating that the previously identified issues have been addressed. Additionally, if any components were replaced or wiring repaired, it's prudent to take the vehicle for a test drive under varied conditions to confirm proper operation of the CVT system. This step will allow you to observe any potential symptoms in real time, thereby ensuring that the repair was comprehensive and effective. To prevent the recurrence of DTC P0712 and maintain optimal performance of the CVT, incorporating effective preventive maintenance practices is essential. Regular inspection of the electrical wiring associated with the CVT fluid temperature sensor can preemptively identify wear, corrosion, or damage that may lead to shorts or interrupted signals. Furthermore, ensuring that CVT fluid is maintained at an appropriate level and quality is crucial, as degraded fluid can lead to incorrect temperature readings. Additionally, regularly updating the PCM software can enhance the vehicle's performance, compatibility, and reliability, thereby decreasing the chances of errors related to processing fluid temperature data. By implementing these measures, vehicle owners can significantly extend the life and reliability of their Honda Fit's transmission system. In conclusion, understanding DTC P0712 and its implications is vital for maintaining the performance of the Honda Fit from 2015 to 2020. The CVT fluid temperature sensor plays a critical role in ensuring that the transmission operates smoothly and efficiently. By identifying potential electrical issues early and addressing them promptly, vehicle owners can prevent more severe transmission malfunctions. Furthermore, adhering to regular preventive maintenance routines promotes long-term reliability. By being proactive about inspections, fluid quality, and software updates, drivers can foster better performance and extend the lifespan of their CVT system, ensuring a smoother driving experience for years to come. Please like and subscribe to the channel. See you next time.